So if you're going to be doing any research that involves multiple dependent variables, the kind of research that you're going to be doing is called multivariate design research. So this is, simply put, a research design that includes two or more dependent variables. Now the fact is, most research is in fact multivariate design. Because if you really think about it, in the real world, we only have so much time, energy, and money to spend. So it would be a waste of all of that to only collect data on a single variable. You know, scientists are people too. We want to make sure that we're getting the biggest bang for our buck, that we are, using our time most effectively. There's numerous examples I could mention. For example, this one researcher conducted a study to measure how feeling disgusted affects people's moral judgment. And in doing this, they also decided they would measure some other things that were convenient to measure at the time. Like they measured how feeling disgusted affects a person's willingness to eat in a particular restaurant. We'll come back to this example in a little bit, but here's another example. In this other example, a researcher decided to conduct a study on odors, like how different kinds of odors could affect a person. So they had one independent variable that had multiple levels, such as there being no odor at all, there being like a lemon smell, a lavender smell, and dimethyl sulfide smell. You know what that is. And this researcher hypothesized that odors could affect people's creativity. But, so that was the main idea. But there was also this other idea that she had as to whether these smells could affect people's moods and their perceived health. So, at the end of the day, she failed to support her hypothesis about creativity. But she did find that people's moods were lower in the dimethyl sulfide condition, and their perceived health was greater in the lemon condition. So what was literally a, failed hypothesis turned out to be something interesting that they could actually write about and potentially publish. Now, when you're doing research like this, where you're measuring multiple dependent variables, there's always going to be the possibility of carryover effects. When I mean carryover effect in this sense, what I'm just saying is, by measuring one thing, that act of measuring could influence the measurements you take later on. So subsequent measurements could be affected. This is why whenever you do this kind of research, we always strongly recommend that you measure the most important dependent variables first. But there's other things that you could do as well. Like you could do counterbalancing. You could counterbalance the order that these dependent variables are measured in. So half the participants get dependent variable 1 measured, and the other half get dependent 2 measured first. An additional measure you can do to make sure that your independent variable was in fact manipulated the way that you expected it to is called a manipulation check. So manipulation checks are also pretty commonly included as additional dependent variables. And there's basically two ways you can check your manipulation. You can explicitly measure the independent variable. So like in the example I mentioned before where people were disgusted, they actually had the participants rate their level of disgust, because they wanted to make sure that if they put participants in a messy room, they actually did feel more disgusted than people who were in a more clean room. But another way you can check your manipulation to see if it actually worked is to just have like an exit questionnaire where you talk to your participants after the study is concluded to just make sure that they noticed that something was going on. And there's 4 different situations where you should do this kind of manipulation check, where you want to include this additional dependent variable just to make sure your independent variable had an effect. So the first situation is if you did any kind of participant manipulation. You know, when it comes to participants, everybody's different. You have those individual differences that can be potentially confounding. So you just want to make sure that all these different unique, beautiful snowflakes, you want to make sure that all of them are being affected in the same way. Another reason why you would want to do a manipulation check is if you have any kind of subtle manipulations in your study. If the manipulations that you're doing in your experiment are so subtle that it's unlikely anybody's even going to notice them, you should obviously make sure that people do. People probably aren't going to be manipulated by something if they never realize it's even there. A third reason why you should do a manipulation check is if you use any kind of simulation. So remember, the whole point of a simulation is to try to produce a realistic setting in a laboratory. Obviously, it's not the real thing, but you want your participants to feel like it's the real thing. You want to see if they're immersed, if they have that kind of experimental realism that's important for doing a simulation. And then the fourth reason why you should do a manipulation check, like the fourth situation where it would be important, is if you used any kind of placebo controls. Remember, placebos are only going to work if the participant believes they're real. The participant has to believe that they're getting a real treatment for you to have those kind of placebo effects. So it's important that you check to make sure that they actually believe they were getting a treatment. Now, besides doing manipulation checks like this, researchers often do other kinds of measurements because operational definitions are never perfect. Researchers often create operational definitions, multiple operational definitions for a single construct, and then they will collect multiple measurements for it. In other words, we have this one thing we want to measure, and we don't know the best way to do it, so we just measure tons of stuff. We measure all kinds of things related to that construct. For example, if you want to measure a participant's stress level, you could just ask them, get self-report data, like how stressed are you on a scale of 1 to 10? Or you could measure participants' cortisol levels, like their hormone levels. We know that's related to being stressed. Or you could do both. So by doing both, you're getting more information about their stress level, which is always a good thing. But when you do collect multiple kinds of information about a single construct like that, you do need to consider one additional thing. How is it you're going to take all this different kinds of information and put it together? Because at the end of the day, we want a single measure, right? So if we're taking like the self-report data and this biological, like chemical data, how are we going to combine those measurements is a very important question. And there's no easy answer to that. How you decide to combine your measurements is really kind of up to you. I mean, you don't just get to pick it out of a hat, of course. You have to go with the conventions for your field of research. But it is important that you have a good idea as to how you're going to put this stuff together before you get started with the collection of data. And one important aspect to doing this is the scaling and weighting of these different measurements. What I mean is, obviously, like if you do this kind of self-report, rating on a scale of 1 to 10, that's going to be a number out of 10. But how is this hormone thing going to be rated? Is it also going to be out of 10? Well, you have to make sure how this kind of stuff is going to be scaled. And then after you do that, after you put everything on the same scale, then you have to consider their relative weights. And by weight, I just mean you might have reason to believe that some variables are more important than others. So those variables should weigh more. And when it comes to the example of the stress level and the cortisol thing, I would argue that the cortisol levels are more important. So you could give that like a weight of 2. Like whatever the rating is for that is multiplied by 2. And then for the self-report, that would have a weight of 1. So we're still combining these things. We're still putting them on the same scale. We're just taking that hormone level stuff more seriously by multiplying its weight in that way.